Right now, gravity is bending space under you. Time is ticking at different speeds, and most of the universe is completely invisible. The world you think you know is just the surface. Let's break down a few incredible scientific truths that are quietly controlling your life right this second. In this video, we're diving deep. We'll explore how gravity literally warps time, how fast you're really moving through space even when you're sitting still, what black holes actually do, and why light isn't as simple as it seems. And we'll get a sense of the truly mind-blowing scale of our universe. Don't worry, we'll cover it all in clear, simple language. Let's start with this. You're never truly still. When you think you're just sitting on the couch, you're actually on a planet spinning at about 1,600 kilometers per hour at the equator. And that planet is orbiting the Sun at a blistering 107,000 kilometers per hour. And our entire solar system is hurtling through the Milky Way galaxy at an even more incredible speed. The point is, you're flying through space all the time, without even feeling a thing. So why don't you feel this constant, high-speed journey? It's because you only feel acceleration, that is, changes in speed or direction. You don't feel constant motion. Think about being on a plane during a smooth flight. Once it reaches a steady cruising speed, it feels calm and still. It's the exact same principle with Earth's motion through space. Now, let's talk about gravity. Einstein completely changed our understanding of it. He showed us that gravity isn't just a simple pulling force. Instead, it's the bending of space and time itself. Massive objects like planets and stars create dents in the fabric of space-time, and everything else simply follows those curves. This curvature of space-time has a weird consequence. Your head ages faster than your feet. Because your feet are slightly closer to the Earth's massive center, they experience stronger gravity, and time runs just a tiny bit slower for them. The effect is minuscule, so tiny you'd never notice, but it's absolutely real. Your head is, scientifically speaking, a little bit older than your feet. This time-bending effect isn't just a fun fact, it's essential for modern technology. GPS satellites orbit far above Earth where gravity is weaker, and they also move very fast. Because of this, their clocks tick at a different rate than clocks on the ground. Engineers have to constantly correct for this using Einstein's equations of relativity. If they didn't, your GPS would be off by kilometers every single day. Moving on to another cosmic mystery: black holes. They're often pictured as cosmic vacuum cleaners, sucking up everything in their path. But that's not quite right. They actually behave more like extremely heavy, dense stars. If our sun were to magically turn into a black hole with the exact same mass, Earth wouldn't get sucked in. We would just continue orbiting it in the same way we do now, only it would be very, very dark. However, getting too close to a black hole is a different story. As you approach one, the force of gravity changes so dramatically over a short distance that the pull on your feet would be much stronger than the pull on your head. This difference in force would stretch you out like a noodle. Scientists have a wonderfully descriptive, if terrifying, name for this process: spaghettification. A lovely term for a truly terrible way to go. Here's something that might change how you see the night sky. All the stars, planets, gas, and dust, everything we can see and interact with, makes up only about 5% of the entire universe. The other 95% is made of dark matter and dark energy, mysterious invisible substances that we can only detect by observing their gravitational effects on the things we can see. We are living in a universe that we can barely even perceive. But you don't need a telescope to see gravity at work. Just look at the ocean. Earth's tides are direct proof of gravity's incredible reach. The moon's gravitational pull literally stretches our planet's oceans, creating high and low tides. The sun plays a role, too. Every single beach on Earth is like a massive live gravity experiment happening right in front of us. Now for a fundamental rule of the cosmos: the speed of light. Nothing with mass can travel faster than light in a vacuum. That speed, about 300,000 kilometers per second, is the universe's ultimate speed limit. It's a cosmic law that shapes our entire understanding of distance, time, and reality itself. This speed limit has a profound implication. Looking into space is the same as looking back in time. When you gaze at distant stars and galaxies, you're not seeing them as they are now. You're seeing them as they were millions or even billions of years ago, because it took that long for their light to travel across the vastness of space to reach your eyes. Every telescope is, in a very real sense, a time machine. If you think black holes are extreme, let me introduce you to neutron stars. This is what's left behind after a massive star collapses and explodes. They are so unbelievably dense that a single teaspoon of neutron star material would weigh billions of tons here on Earth. Imagine an object the size of a city that has more mass than our entire sun. Its gravity turned up to a level that is pure insanity. You know that famous line from the movie, Alien. In space, no one can hear you scream? Well, for the most part, it's true. Space is almost a perfect vacuum, which means there's no medium, like air, for sound waves to travel through. So those massive, noisy explosions you see in sci-fi movies would actually be completely silent in the vacuum of space. The reality is much quieter, and perhaps even more terrifying. Have you ever wondered why we don't just fly off the Earth, given how fast it's spinning? It's a great question. The answer is simple. Gravity is much, much stronger than the outward push or centrifugal effect caused by the spin. If you're at the equator, the spin does slightly reduce your weight, but it is not nearly enough to overcome gravity's powerful grip and launch you into space. Here is a concept that can be tough to wrap your head around. The universe doesn't have a center. Because space itself is expanding, all the galaxies are moving away from each other. From the perspective of any single galaxy, it looks like all other galaxies are rushing away from it. This means there's no special middle point where the Big Bang happened. Every point can be considered the center of its own observable universe. Finally, let's bring it all back to you. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of these essential elements were forged in the hearts of ancient stars that lived, died, and exploded billions of years ago. You are, quite literally, made of stardust. The universe isn't just something out there. It is inside you. So the big takeaway is this. Space isn't some far-off, distant place. You're in it. Gravity, time, light, and matter connect everything in a beautiful, intricate dance. You're not just standing under the universe. You are a part of it, riding a spinning rock through a cosmic ocean that is far stranger and more beautiful than it first appears. If these facts bent your brain a little, hit that like button, share this with a friend who loves science, and subscribe to Info Spark Zone. Next time we'll go even deeper into the secrets of space, time, and the reality we think we know. Thanks for watching.